Hello, Programming 11. Welcome back to the Pew Pew game. We are going to be improving the enemy today. The enemy is pretty dull. It doesn't, it's a target. We can shoot it, but the game still lacks any sort of danger, any tension, because there is none. So I'll just show you. I've sped up the game a little bit. The first thing we're going to work on today is making it so they don't spawn in an obstacle. I've sped it up so we can see like it'll spawn a whole bunch of bad guys, and see like a lot of them spawn on top of the obstacles. That seems kind of weird, I would say. I would expect them to not be in the middle of a wall or whatever these obstacles are supposed to be. That would be a problem. So we're going to make it so that they cannot spawn on top of the objects, the purple objects, the obstacles. This is actually a pretty awesome AP comp sci question. Like, given this system of objects, how do you make one group of object not spawn on top of another one? And it's a pretty tricky question, so we're going to go over it, and this is going to be the content of this entire video. So we do have the tools available to do this. We just have to create a little bit, build on top of those tools and create another tool to check for if we're touching an obstacle. So I'm going to actually do this in reverse order. This is called top-down programming, where you sort of imagine the tool exists and then use it and sort of figure out what that looks like first. And then once you have figured that out, you go and design the tool. So the tool that I want to design is some kind of function that tells me, am I touching any obstacle? Like, am I touching, and by I mean, is this enemy that's being created, up here in this enemy class. As soon as it spawns, I wanted to check, hey, did I end up spawning on an obstacle? If so, do it again. Try a different spawn point. So here's what I would like to do. So, I have to put the super part of the constructor first. You can't put anything in front of it. I tried to type in, like something like this. I can't do that. Int x equals 1 or something. You'll see that it complains. Like this constructor call must be the first statement in a constructor. So we can't put that there. So we sort of have to use the superclass constructor thing. And then after it's done, we can be like, oh, so did I end up touching an obstacle? And then keep on doing it over and over again, or at least changing the location over and over again until it's not touching. So the way I'm going to do this is I'm going to assume that there's some function called touching obstacle that just tells us if this enemy is touching an obstacle or not. I'm just going to assume that that's true. And here's some things I'm going to assume about it. So I guess actually what I just said is what I'm going to assume about it. But also, I'm going to assume it returns true or false, so that I can say something like if touching obstacle. And what's tricky about this is because we already made a touching function, it's going to check to see if we're touching any of the obstacles in the game. So it's probably going to have some kind of loop built into it. And even more fancy, instead of saying if, I'm going to say while touching obstacle, so that it can repeat over and over again. And don't mind too much this error. Like I see that it's like saying this function does not exist. Well, yeah, we know. That's what top-down programming is all about. You assume this function exists, you figure out how to use it, and then you go and fill in the details. It's a really good way to program, and this is something that you'll see more and more as you go higher and higher in computer science, where you do the top level first, and then you work your way down, as opposed to defining touching obstacle first, and then trying to figure out how to use it. Okay, so if this is my function, I would say something like x equals a random number between 0 and width, and y equals a random number between 0 and height. So this while loop is fantastic. If we have, and we're assuming we do have a touching obstacle function that tells us whether this enemy is touching an obstacle or not, then, as long as we're still touching an obstacle, we're going to respawn the enemy. So just do this over and over again until we're not touching an obstacle, in which case these coordinates will be set and we're done. So that's going to save our bacon, or at least our enemy's bacon, from spawning inside of an obstacle. I'm going to just move on. So now that we've done the top layer, we're going to do the bottom layer second. So now we're actually going to go figure out what touching obstacle is going to be. You first have to decide where are you going to program the touching obstacle function. You could just put it in enemy, right now. Nothing else needs to know if it's touching an obstacle or not. I mean, I guess the bullet does, but it's already got this loop built in, and it has to check for other objects anyways. So, it's basically the enemy is the one that needs this. But you never know, right? Maybe in the future, it might be important for an object to know if it's touching an obstacle or not. So I'm going to bake this into the game. I'm going to put this into the game object class. So, right beside my touching function that I made previously, and notice that I'm keeping that bottom brace of our class, in our sights here. I'm just going to move that down. I'm going to make this Boolean touching obstacle function, and this again is in the game object class. Obstacle. There we go. It's in the game object class, and my goal here is to write this as a loop that'll go through and check every object in the game if it's an obstacle and if we're touching it. And if it is, we'll return true, and if it's not, we'll return false. You'll see that it still underlines it as an error because we have to return true or false. As soon as we put Boolean here instead of void, then it's not going to be happy until we return true or false. So what I'm going to do is I'm going to make a while loop. It's going to look, a lot like the game while loop that we made before in the game function. And you might even want to pause the video and just go and read over this and remind yourself, what are these different components. It might, if you're, feeling confused at all, that would be a good thing to do. So, assuming you are feeling comfortable with it, I'm going to just go ahead and put in the nuts and bolts of it. So, while I is less than objects.size. And of course, if you have any questions, do not hesitate to write to me in the discussion channel, or an email would be great to receive from you as well. So here's the nuts and bolts of our while loop. We're going to start at the beginning of the list of objects. We're going to go as long as we still have objects all the way to the end, and then we're going to go up by one each time, going from one object to the next. And what are we going to do? Well, we're going to ask a question. As we go through these list of objects, we're going to say, hey, if it's an obstacle, this object. Actually, I guess we have to get the object first, hey? So I'm going to get the object just like we do here. Nope. Nope. Yeah. We have to get the object, and then we can test to see what kind of object it is and whether it's touching us or not. So I'll copy that over, I guess. So this is what we need here. So we're going to get the object, and then we can say, ooh, if that object, obj, is an instance of an obstacle, and we're touching it, then I guess the answer is true. We are touching an obstacle. And then we go on to the next one. So we're not quite done yet, because what happens if we're not touching any obstacles, right? So this now can say, yes, we are touching an obstacle. We also have to be able to say no if we're not touching an obstacle. And you might be tempted to put an else here, but that's wrong. And here's why. If you put an else there, then as soon as you find an example of an object that we're not touching, it'll return false right away, and it won't check through the rest of the objects. So that's not what we want. We want to go and see, are we looking, we're going to look through all of the obstacles and see if we're touching any of them. So the best thing to do is, at the end of the loop, if we haven't returned yet, because when you return, the function's done. So it won't get to the end of the loop if we ever found that we were touching an obstacle. So if we got to the end of the loop, and we never returned yet, then we can assume we weren't touching any obstacles. So I can return false at that point after the loop is done. Notice the brace here matching with the while loop. So that's basically a pattern that you're going to use all through Programming 12 and AP Computer Science, where you return true or false inside of the loop, and then you return the opposite at the end of the loop. So that's a pretty handy thing to know. All right, it's looking good. So let's go back to our enemy. Notice this works now. Touching obstacles seems to be functioning. It doesn't complain about it anyways, and we can test it right now. We'll just see if any of our enemies spawn on an obstacle. Let's see. It's accelerated right now. Yours won't spawn this fast, but I've accelerated mine just to make sure that I can test it. We can see all these enemies spawning, but none of them are spawning on the purple. None of them are spawning on the obstacles because if they do, we keep respawning them. And the way we check to see if we're touching an obstacle is basically we go through all the objects and we see if we're touching one, and if we're not, we can say that. If we are, we can say that. So that's the story. Oh, it's turning so orange. I'm starting to second guess my color scheme. So I don't know what to say about that, but not much I can do. Except for I should just go and like, explode a bunch of DR. It's fun to like blow things up sometimes. Oh, it's kind of cathartic actually. Maybe you should just go and like blow up some enemies for a while. It feels good to just like get rid of them. Although it's a little bit stressful because they're coming back. Oh no. No, just kidding. I'm just being weird now. Anyways, thanks everybody. I hope you had a good time with this lesson. In the next lesson, we're going to do something with the enemies where we make them shoot. They're going to make the enemy shoot back at us. And I think that'll be a pretty pivotal moment in our project. Okay, thanks everybody.